Hello, in this video, I'm going to talk about different types of energy, potential energy, kinetic energy, potential elastic energy, and work, and how to calculate them. First of all, our content and language objectives. Our content objective is I can distinguish between different types of energy. And a language objective is I can write questions for a dichotomous key used to distinguish between different forms of energy. The first type of energy we're going to talk about is potential energy or positional energy. It's the energy that's stored because of the position of an object. So if an object is off the ground, it has potential energy, just like the ball that's shown in the image to the right-hand side of this picture. Potential energy is solved by taking mass times gravity times height. And so in this scenario, it says if the mass of this Boeing 747 is 333,400 kilograms and it's 19 meters off the ground, what is its potential energy? And so again, potential energy is mass measured in kilograms times gravity, 9.8 meters per second, or sometimes I'll use 10, times height in meters. How would you go through and solve this problem? Again, you just have to identify the different units, mass measured in kilograms. Acceleration is sometimes just a given. On Earth, it's 9.8 meters per second, and the height given to you in this problem is 19 meters. Find the product of all of those three values, and you come up with 62,079,080 joules. The second form of energy we're going to talk about is kinetic energy. It's energy due to motion. It says kinetic energy is the energy possessed by a body as a result of being in motion. Kinetic energy, it says what is the kinetic energy in the example below. You see a car with a mass of 950 kilograms moving 29 meters per second. And so energy kinetic, E sub k, is equal to 1/2 times mass in kilograms times velocity squared, measured in meters per second. And so how would you go through and solve this problem? You just have to, again, look at the units. You see kilograms, you see meters per second, and you would just multiply them to figure out what is the energy kinetic, the kinetic energy of this problem. And I came up with a value of 399,475 joules. Elastic potential energy is, again, a stored energy, a potential energy, but instead of based upon your position, it's based upon some storage in a spring. So elastic potential energy is the energy which is stored when a body is deformed, such as a coiled spring, or a bungee cord could work as well. Elastic potential energy is based upon two different factors, K and X, that we'll talk about in just a moment. In the example problem here, it says a 3-kilogram object compresses a spring 0.6 meters, giving it 8.1 joules of energy. What is the spring constant of this spring? And so potential elastic, sometimes written out as PEEL, is equal to 1/2 K. K is a spring constant. How springy is your spring? If a spring is easily moved, it would have a low spring constant. If it's very difficult to move, like shocks on a car, it would have a very high K value, times X squared. And X is the stretch or compression distance. How much from outrest you're pushing the spring together or pulling it apart. In this example, we are given our potential energy elastic of 8.1 joules. You are given your distance that it is stretched, and you're asked to solve for the spring constant K. So when we rearrange this equation, plug in the values that we know, what we come up with is a spring constant that is 45 Newton meters. That's the unit for spring constant. Newtons divided by meters is for our K value. Finally, the most difficult of the bunch, work, is sort of an accounting for energy sometimes. Work is done when a force that is applied to an object moves that object. And so work is equal to force times distance. It's one way that you can calculate work. And so it says if the man pulls on the box for 8.5 meters, what is the work done? Again, work, again measured in joules, all these different forms of energy are measured in joules, is equal to force measured in newtons. Force, by the way, can also be found by taking mass in kilograms times acceleration measured in meters per second. But work is equal to force times distance measured in meters. Solving this problem, again, we are solving for work in this case, and work is equal to force in newtons times distance in meters. The product in this example is 297.5 joules. Work, though, there's another way that you can solve for work, and we'll talk about that in a moment. Determining your energy type. A lot of people just got sort of stuck on what type of energy do I have? And so if you're solving for potential energy, what you'll see is that an object is going to be off the ground. The question I would ask myself for first when solving a problem is the object off the ground? If the answer is yes, you have stored energy due to position, positional energy, potential energy. And so that 1 kilogram object, even if it's moving, even if it's dropping, it's still off the ground, so it has potential energy. An object can have more than one type of energy. Second question I'd ask is the object moving? If yes, then you have kinetic energy. A third question that you can ask is a spring or something being compressed or stretched, be it a bungee cord, spring, anything else? If yes, you have elastic potential energy. What I would always try to do first is figure out what type or types of energy that you're dealing with. Is there a force? Is there a push or a pull applied to an object? If yes, there's work that's being done. That thing that I was talking about earlier with work, sometimes what there is there's a difference between your starting and ending energy. We'll talk about in a separate video a concept that's called conservation of energy. But if you have a work in that I'm hovering around now, that's 40 joules at the start of some circumstance, and you have a work out and energy at the end that's 32 joules, work can also be the difference between your starting and ending energy. That is the end of this video demonstrating how to solve for different types of energy. If you have any questions, as always, you're welcome to stop by the homework help hours or during period 1A. Thank you very much and have a great day.